This is question 42 from the GATE 2016 session 3 EC paper, where we are given this circuit with an NMOS transistor having a capacitor connected from its drain to gate. The transistor has a GM of 0.01 Siemens and it does not have internal parasitic capacitance and channel length modulation. We are asked to find out what the small signal input pole frequency is in kilohertz. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. This is the NMOS transistor with the following small signal model. To be noted here is that there is no output resistance on the model because, well, there is no channel length modulation as mandated by the question. And because we are in saturation region, the model has the current into the drain as Gm times V. The saturation region for a MOSFET is given by the condition VGS greater than VTH and VD greater than VG minus VTH. So first, let us derive a relationship between V0 and Vi. So to do that, I will first get the small signal model for this circuit. Going to ground because in small signal we ground the DC sources. Now we can analyze this circuit to get a relationship between Vin and Vout, right? So I will use the method of signal flow graph to generate the transfer function. First we define our loop currents I1, I2, and we leave our node voltages as is. Let's establish our relationships between the quantities. I1 is Vin minus V by Rs. I2 is I1 minus GMV, right? I2 is flowing like that, I1 is flowing like that, GMV is flowing like that. As for the first, I1 is flowing like this, and this is Vin and this is V. Third, we have Vout, which is just I2 into, let's call this the resistor R. So we have Vout is equal to I2R, and the final relationship is Vout, and this is I1 into 1 by SC. That is, we have the drop across this capacitor and Vout. So Vout plus this drop should be Vin. That is Vin and that is V. That is Vout plus the drop across this capacitor should be the voltage V. That is V is equal to Vout plus, what is the voltage drop on that capacitor? It is I1 times 1 over SC. Right? We can draw the signal flow graph for this as so. Vi going to I1 and V going to I1. This is 1 over Rs. This is minus 1 over Rs. Now with the signal flow graph, we need to identify the loops. So we have two loops, we have three loops. The loop gains can be given as L1 is minus 1 over SRSC. The determinant, since all the loops are touching, is simply 1 minus L1 plus L2 plus L3. So input is Vi, output is V0. So we have Vi and V0. There are two paths. This straight path is P1 and this other path is P2. We have the path gains as P1 is equal to 1 by Rs times 1 by Sc times minus Gm times R. That is this into this into this into this. And delta 1, since all loops are, since this path touches all loops, is just going to be 1. And P2 is equal to R by Rs. That is, P2 is the product of this and this. Again, since P2 touches all the loops, delta 2, its cofactor is going to be 1. Finally, we get V0 by Vi using the Mason's gain formula as P1 delta 1 plus P2 delta 2 by delta. If you simplify this, you will get this as so you have a 0 in the numerator and a pole in the denominator. Since the question is asking us for the input pole frequency, we will take the denominator term. So the pole frequency will be, this is in radians per second. Now substituting the values for Gm, R, Rs and C, we get that omega, or we get that the pole in radians per second is 357.14 kiloradians per second. The frequency in hertz, which is 56.84 kilohertz. Thus the answer in kilohertz is 56.84.